Hello viewers, in today's class we are going to discuss an important problem from conic sections related to ellipse, right? So here we are given an equation of ellipse and we'll find out all the important parameters related to ellipse. So let us start. So here we are given the Cartesian equation of an ellipse, and here we'll find out the length of major axis, the length of minor axis, the eccentricity, the foci, the vertices, the center, and the equation of the directrix of the ellipse and the area of the ellipse. So let us first write this Cartesian equation of ellipse in a standard form. So by standard form, we mean that we have to express this equation in this form, that is x square over a square plus y square over b square is equal to 1. Right? So now I will express this equation in this form. So we can write this equation as x square over 1 over 2. Then we can write y square over 1 over 3 is equal to 1. Right? So these two equations are equivalent equations. So we have expressed this equation in this form. So if we compare this equation with this one, then we can see that a square is given by 1 over 2 and b square is given by 1 over 3. So now the value of a is 1 over square root of 2, taking the square root of 1 over 2, and the value of b is 1 over square root of 3. Right? And if we look at the values of a and b, then we can easily see that a is greater than b, because 1 over square root of 2 is greater than 1 over square root of 3. Right? So it implies that the given ellipse is an horizontal ellipse. Right? So this is a horizontal ellipse. So let us first draw a rough diagram of this ellipse. So now we have the ellipse like this, and we can draw the axis. These are x-axis and y-axis. This is x-axis, this is y-axis, and this is the origin. Right? So since a is greater than b, so the ellipse is in a horizontal ellipse, and here these 2 points may be denoted by, say, a prime, and here we have a. Here these 2 points may be written as b dash, and here we have b. Right? And the foci may be located like this. These 2 points are known as the focus. So here we have f1 and here we have f2. Right? So let us quickly explain the diagram of this ellipse. So here this point O is known as the center of the ellipse, right? So this is the center of the ellipse, and here this length, that is A dash A, is known as the major axis. Right? This is the major axis, and this length, that is b dash b, is known as minor axis. Right? And f1 and f2 are known as the focus or the foci of this ellipse. Right? Okay. So whenever we have an ellipse of this type, that is x square over a square plus y square over b square is equal to 1, then these two endpoints or the extreme points are known as the vertices of the ellipse, right? And let us first quickly write the coordinates. So here this a dash point is having the coordinates minus a comma 0. This a has the coordinates a comma 0, and here this point, that is b dash, has the coordinates 0 comma b, and b has coordinates 0 comma minus b, right? So the intersection of x-axis and y-axis, which are respectively the major axis and minor axis, this point O is the origin. So this has coordinate 0 comma 0, and F1 and F2 are the two focus. So F1 has coordinates c comma 0, and here we have minus c comma 0, right? And the relation between A, B, and C is given by C square is equal to A square minus B square, right? So this is an important relation which connects C, A, and B. So now let us quickly find out the parameters related to the ellipse. So here the first one is the length of major axis, right? So the length of major axis is given by this length, that is a dash a, and this is given by 2 times a, right? And a is 1 over square root of 2. So this is 2 times 1 over square root of 2, that is 2 over square root of 2. And let us rationalize it, the numerator and denominator. So we have square root of 2 over square root of 2. So we have simply square root of 2, right? So here these terms get cancelled. So the length of major axis is square root of 2. Let us find out the length of minor axis. So the length of minor axis is given by this line segment, that is b dash b. So we have b dash b is equal to 2 times b, right? So we have 2 times b. B is 1 over square root of 3. So this is 2 over square root of 3, and we can rationalize it. So we have square root of 3 over square root of 3. So this is the 2 times square root of 3 over 3, right? Okay, now let us find out the value of c. So c square is a square minus b square. A square is half and b square is 1 over 3. So we have 3 minus 2 over 6. So this is 1 over 6. So c is given by 1 over square root of 6, right? Now let us find out the coordinates of the foci, that is F1 and F2. So we have F1 is given by c comma 0. So here we have the value of c, that is 1 over square root of 6 comma 0, and F2 has the coordinates minus c comma 0. So here we have minus 1 over square root of 6 comma 0, right? So if we combine both these foci, that is F1 and F2, then the focus is given by plus minus c comma 0. So we have here plus minus 1 over square root of 6 comma 0. Now let us find out the eccentricity of this ellipse. So the eccentricity is denoted by E, and this is given by C over A, right? So C is given by 1 over square root of 6, and A is given by 1 over square root of 2. So simplifying it, so we have 1 over square root of 6 times square root of 2 over 1. So we have square root of 2 over square root of 6, that is square root of 2 over 6, that is 1 over square root of 3. So here we have 2 times 3 is 6, right? Okay, now let us find out the length of the latus rectum. So the latus rectum is defined as a line which is perpendicular to the major axis of this ellipse and which passes through the focus, right? So here if we draw a line like this, then this length is known as the length of latus rectum. Similarly, the other latus rectum is drawn like this, that is, this line passes through the focus f2 and it is perpendicular to the major axis, and the length of latus rectum is given by the formula, that is 2 times b square over a, right? So we have 2 times b square. B square is given by 1 over 3 and a is given by 1 over square root of 2. So this is 2 over 3 times square root of 2 over 1. So this is 2 times square root of 2 over 3. So this is the length of the latus rectum. Now let us find out the equation of directrix, right? So equation of directrix is given by x is equal to plus minus a over e, right? So this is the equation of directrix of an ellipse, and a is given by 1 over square root of 2, and e is that is eccentricity is given by 1 over square root of 3. So x is equal to plus minus, and we can take square root of 3 to the numerator. So we have square root of 3 over square root of 2. So we can now write x is equal to plus minus square root of 3 over 2. So here we have two lines parallel to y-axis. So the first one is given by plus, here we can write positive square root of 3 over 2, and the second line is given by negative square root of 3 over 2, right? And this line is parallel to y-axis and it is situated somewhere here, right? So this is the first directrix whose equation is x is equal to plus square root of 3 over 2, and the second directrix, it lies somewhere here, right? So this is the second directrix whose equation is minus square root of 3 over 2. So now let us find out the area of this ellipse, right? So area of the ellipse is given by this formula, which can be obtained by using integral calculus. So we have the area of ellipse as pi times a times b, where a is 1 over square root of 2 and b is 1 over square root of 3. So we have pi times 1 over square root of 2. Here we have 1 over square root of 3. So this is pi over square root of 2 times 3, that is equal to pi over square root of 6, that is square units. So the area of this ellipse is given by pi divided by square root of 6 square units. So viewers, this is how we can find out all the parameters related to the ellipse.